Introduction to Well Control. The importance of well control. To prevent the uncontrolled, catastrophic release of high-pressure fluids, oil, gas, or salt water, from subsurface formations. These uncontrolled releases of formation fluids are referred to as blowouts. The following video shows an example of a blowout. Fundamental principles of well control. The function of well control can be conveniently subdivided into three main categories, namely primary well control, secondary well control and tertiary well control. These categories are briefly described in the following paragraphs. Primary well control. It is the name given to the process which maintains a hydrostatic pressure in the wellbore greater than the pressure of the fluids in the formation being drilled, but less than formation fracture pressure. If hydrostatic pressure is less than formation pressure, then formation fluids will enter the wellbore. If the hydrostatic pressure of the fluid in the wellbore exceeds the fracture pressure of the formation, then the fluid in the well could be lost. In an extreme case of lost circulation, the formation pressure may exceed hydrostatic pressure, allowing formation fluids to enter into the well. An overbalance of hydrostatic pressure over formation pressure is maintained. This excess is generally referred to as a trip margin. Secondary well control. If the pressure of the fluids in the wellbore, i.e. mud, fail to prevent formation fluids entering the wellbore, the well will flow. This process is stopped using a blowout preventer to prevent the escape of wellbore fluids from the well. This is the initial stage of secondary well control. Containment of unwanted formation fluids. Tertiary well control. Tertiary well control describes the third line of defense, where the formation cannot be controlled by primary or secondary well control, hydrostatic and equipment. An underground blowout, for example. However, in well control it is not always used as a qualitative term. Unusual well control operations listed below are considered under this term. A kick is taken with the kick off bottom. B. The drill pipe plugs off during a kill operation. C. There is no pipe in the hole. D. Hole in drill string. E. Lost circulation. F. Excessive casing pressure. G. Plugged and stuck off bottom. H. Gas percolation without gas expansion. We could also include operations like stripping or snubbing in the hole, or drilling relief wells. The point to remember is what is the well status at shut-in. This determines the method of well control.